Hello everybody. Today what we're going to do is we're going to go over what is the definition of a significant figure and how do you determine if a figure is significant or not. As we talked earlier, we talked about making measurements and the importance of when you make a measurement, there are digits that we know with certainty, and we are also trained to estimate the very last digit of a measurement. So when it comes to a significant figure, these are the numbers in the measurement that have meaning. They're important. And significant figures are basically all the certain measurements as well as the estimated digit. So it's not just all those digits we know with certainty. That very last digit that we estimated is the last significant figure in a measurement. So significant figures, when you do make a measurement, does include the estimated digit, which will always be the last digit in a measurement. Now, here's how we're going to determine. I'm going to show you some rules as to when a digit is significant and when it's not. It has actually to do with the zeros. If you look here, I have all the rules written down here, but we're going to break them down. Okay? Rule number 1 basically says that if you're a digit between a 1 and a 9, in other words, a non-zero digit, the rule says that that figure is automatically significant. Okay? Here's what I'm going to do. I'm going to give you some examples. Okay? The first one is listed here, the number 1562. All 4 of these digits here are non-zero digits. Therefore, all 4 of those digits are significant. Let me provide you with a couple more examples. Okay? So if you had a measurement that was 43.6, okay? Remember that these are the certain digits. This is the estimated digit, but the estimated digit is considered significant as well. Plus, rule number 1 says if you're a non-zero digit, you're automatically significant. So this number has 3 significant figures. Let's go over one more. So you measure something like the balance. You weigh 147, let's say 0.7 pounds. All of these digits are non-zero, therefore all 4 are significant. And yes, the 7 here is an estimated digit, but that's also significant. So rule number 1, if you're a non-zero digit, you're automatically significant. So then, let's talk about the zeros. The zeros may or may not be significant. And what I'm going to do here is I'm going to break up zeros into 3 categories. Rule number 2 talks about something called leading zeros. By definition, a leading zero is a zero that is found at the front of the number. Notice this 0 here, and decimal point doesn't really matter. All of these zeros before this number 1 here, they're known as leading zeros because they are at the front of the number. Well, here's what the rule says. Leading zeros are never significant, ever. Therefore, in this number, only the 1 and the 5 are significant digits. So that number only has 2 significant digits. Let me give you some more examples. So let's say I had 0.3. That zero's a leading zero. So that's not significant. So only the 3 is significant. Okay, that one has 1 significant digit. Let's say I had 0.000511. All of these zeros are leading zeros. They are not significant. So this number has 1, 2, 3 significant figures. And the reason is back to rule number 1. They are non-zero digits. So, leading zeros are never significant. Okay? Now let's go and look at the third rule. Third rule are known as confined zeros. A confined zero, also known as a captive zero, you could use either term, is a zero that is in between 2 non-zero digits. Notice how this 0 is between a 3 and a 1, which is two non-zero digits. According to rule number 3, a confined zero or a captive zero is always going to be significant. Always. So, this number here has 4 significant digits, the 3, the 1, and the 5 because of rule number 1, and the 0 is because of rule number 3. It's a confined zero, therefore it has 4 significant figures. So let's put a couple of examples. So let's say we got 305, our area code. That 0 is between a 3 and a 5. It's between two non-zero digits. Therefore, that 0 is significant. This number has 3 significant figures. Look at this number. 1, 2, 0, 0, 0, 0, 9. All of these zeros are between a 2 and a 9. As long as there's a non-zero digit in front and behind, the rule says that all of these zeros are significant. So this number has 1, 2, 3, 4, 5, 6, 7 significant digits. Okay, it doesn't matter how many zeros there are. If there's a non-zero digit in front and behind, and these zeros are sandwiched in between, which are known as confined or captive zeros, the rule is that they are always significant. Here's another example. 3. Let's put here 3.005 and let's put here 12 or 120.09. These two zeros are between a 3 and a 5. So that number has 4 significant figures. These two zeros, the decimal point doesn't matter. Both zeros, whether they're in front or behind the decimal, these two zeros have a 2 and a 9 in between them. They're in between a 2 and a 9. So, all 5 of these are significant. So, a confined or a captive zero, which is a zero between two non-zero digits, the rule is they are always significant. Now comes the last rule. This is the most difficult one. Trailing zeros are zeros at the back end of a number. Now, in order to explain this, let's do something creative here. This is the only time that you actually have to pay attention to the decimal point. So the topic is a trailing zero. What is a trailing zero? Simple. A zero at the end of a number. What we're going to do is, let's call this part A, and we'll call this part B. In part A, a trailing zero with, I'll abbreviate here, with a decimal point present. And in part B, we're going to say it's with a decimal point is absent. These are two completely different rules. Let me show you. First, let's say I put 42.10. That zero is a trailing zero. Notice there's a decimal point. It's present. It's right there. Here's the rule. If you have a trailing zero, like this one right here, and there's a decimal point present, the rule is they are always significant. Think about it. Do I really have to write that zero there? The answer is no. 42.1 and 42.10 have the same exact value, yet the zero's written there for a reason, and I'm going to tell you what that reason is. The reason that zero is there is because in the measurement, that spot was the estimated digit. Okay? That zero, since it was estimated, is part of the measurement, therefore it's significant. So if you see a zero written at the end, it's because it has meaning. Let me give you another example. Let's say I had 320.0. Both of these zeros are considered trailing zeros. There's a decimal point. The rule says if there's a trailing zero and there's a decimal point, they're significant. So all 4 are significant. Now remember, they're all significant. This is rule number 1, non-zero digits. And this is due to rule number 4, 2 trailing zeros with a decimal point. Okay? Even a number like this that looks ridiculous, like 5.000, I know that number looks ridiculous. I know those zeros don't have to be there, yet they are. Okay? The fact that they're there, they're trailing zeros, and that there's a decimal point, the rule is that if those zeros are written there, they're written there for a reason. Therefore, they're significant. This one also has 4 significant figures. Now, look at the other side of the coin. If you have a trailing zero and there's no decimal point present, it's absent, the rule says that they are never significant. Okay? We have a term for this. I'm going to refer to them as placeholders. I'm going to write this down and I'll go back to that word in a minute. But trailing zeros that are not significant function as what we call placeholders. Here's an example. 1,200. Notice those are trailing zeros. But notice there's no decimal point written at all. According to the rule, only the 1 and the 2 are significant. These 2 trailing zeros are not significant. Now, why are they there? Because if I don't put them, the number 12 and the number 1200 do not have the same value. The zeros are there as placeholders to provide the correct value, but the zeros were not part of the measurement. That's why they're not significant. Let me give you another example. Let's say we had the number 3 million. Guys, all of these zeros are placeholders. You don't see a decimal point. They're all trailing zeros. This only has 1 significant figure, the 3. Okay? All those zeros are placeholders. Let me give you another example. The number 30. The way I wrote this number right now, this only has 1 significant figure, the 3. Now, this is something you're going to see in chemistry. If I were to put a decimal point, even if I don't write anything behind it, just the decimal point there, automatically that decimal point reverts back to this rule over here. If you see a decimal point, this no longer has 1, it now has 2. So the only time that you got to pay attention whether the decimal point is present or absent is when you have a trailing zero. Okay? Now I'm going to go ahead and give you some examples. Here are some that are worked out for us. The question is, how many significant figures are in each of the following? Well, if you look at the first number, these 2 over here are leading zeros, so they don't count. Rule number 2, leading zeros are never significant. Now, this one is a trailing zero. Guess what, guys? There's a decimal point right here. And because there's a decimal point right there, rule number 4 says if you have a decimal point and it's a trailing zero, it's significant. So this number has 1, 2, 3, 4 significant figures. Okay? If you look at the next example, the 3 zeros that you see here are confined or captive zeros. If you remember the rule, confined zeros are always significant. So we know the 5 and the 3 are significant due to rule number 1. Here, all 5, 1, 2, 3, 4, and 5 are going to be significant. Now, this third example is something I didn't talk about earlier, and I'm going to go ahead and tell you now. What you're looking at is something called a conversion factor. I'm sure some of you know a few, maybe 1 foot is equal to 12 inches. A minute is 60 seconds, right? An hour is 60 minutes. This example is 1 meter is equal to 10 decimeters. Okay, these are called conversion factors. Well, conversion factors, if you ever see one, like in this example, they're known as exact numbers. And here's the answer. Whenever you have a conversion factor, because it's an exact number, it has an unlimited number of significant figures. If you're given a conversion factor, what you're going to say is infinite. Okay? That means unlimited. Infinite, it goes forever. Conversion factors, okay, will always have an infinite amount of significant digits because they are what we call exact numbers. I just want you to keep that in mind for future reference. Now, this next one is important. You have a number here in scientific notation. Here's what I want you to do. This one's actually really easy after I explain it. Whenever you're given something in scientific notation, ignore the base component. Don't even look at that. Focus only on this portion of the number. And use the rule. If you recall, aren't those zeros trailing zeros? They are. And there's a decimal point. According to our rule, trailing zeros with a decimal point are significant. So if I asked you how many significant digits this number in scientific notation has, the answer is 4. It's all 4 of these. You ignore this part. Don't even look at it. Cover it with your hand. Okay? Now, let's look at the next one. Guess what all of these zeros are called? Leading zeros. Rule says they're never significant. So the only digit here that's significant is the 2. So this one has one significant figure. And the final example, you have 10,000. They're all trailing zeros. I don't see a decimal point there. If you look at your rule, trailing zeros without a decimal point are not significant. Therefore, the only significant digit here is a 1. So I would go by this. I know the word ambiguous is used. Just put 1 if you're asked. Okay? You don't have to put ambiguous. By the way, those other 4 zeros that are not significant, they're only there as placeholders. They're not part of the measurement, but they're there as placeholders to give this number the proper value. Okay? Now, I'm going to let you guys try this one. Now, before we do that, there's an example that I'm going to write here, okay, that covers all the rules, and then we'll do these together. Look at this example. This is a great example. Let's say I gave you 0.002040. Okay, I want you to think about this. And this question involves all the rules that I taught you put into one question. How many significant figures does this number have? Think about it. Okay. If you said 4, you are correct. Now let me show you which 4 and why. Let's break it down. These first 3 zeros are not significant because they're leading zeros, so they don't count. The 2 and the 4 are significant because of rule number 1. They're non-zero numbers. The 0 between the 2 and the 4 is a confined zero. The rule says that they're always significant. And the final 0 is a trailing 0, but there's a decimal point. According to the rule, if you have a trailing 0 with a decimal point, it's significant. So if you answered 4 to this, you're doing a good job. Okay? You've got your rules down. Now, let's take this to a test, and let's go through A through G. I'm going to pause it for a minute, work them out, and then I'm going to go ahead and give you the answers. Okay, I'm going to assume you finished doing these. All right, look at letter A. Letter A has only 2 significant figures because the first 3 zeros are leading zeros. So only the 3 and the 5 are significant. So this one only has 2. So if you answered that, you are correct. Letter B. This 0 here is a confined 0, which means it's significant. This 0 here is a trailing 0, and there's a decimal point, so it is also significant. And we know that non-zero digits are significant. So if you answered for letter B that all 4 are significant, you are correct. Okay? And then C should be one of the easier ones because all 4 digits are non-zero. So we know from the first rule that all non-zero digits are significant. So they're 4 is the correct answer. Now remember what we did with part D. If I give you something in scientific notation, you're going to ignore this component and you're just going to look at this. And all three numbers there are non-zero digits. Therefore, that one has only 3 significant figures: the 2, the 9, and the 7. Okay? Look at letter E. I don't know if you recognized it or not, but that is called a conversion factor. And what we said about conversion factors is that they are what we call exact numbers. And when you have a conversion factor or an exact number, the number of significant figures is infinite. That would be your answer. Infinite or unlimited. Okay? That applies to all conversion factors. Let's go to letter F. If you look at letter F carefully, all those zeros are called trailing zeros. But I see a decimal point. If you go back to the rule, trailing zeros that have a decimal point are significant. So here, all 5 of these numbers are significant figures. Now, G is the opposite of F. They are also trailing zeros. However, there's no decimal point. And the rule says that if you have trailing zeros with no decimal point, that they are not significant. In fact, what they're called is placeholders. So this one has only one significant figure, which would be the 1. Okay? So hopefully you're getting the hang of this. I'm going to leave you with one more exercise here. Okay? Extra practice is always good. Here's a Skill Builder 2.4. I'm going to give you a moment to pause, and we'll go ahead and go over these. Okay, I'm assuming we're back here. So let's go over the answers. So for the first one, you should have said 4. The rule is rule number 1. They're all non-zero digits. For number 2, the answer is 3. Let me give you the rationale. The first 3 zeros here are leading zeros. But the last one is a trailing zero, and there's a decimal point, so it is significant. So the answer to that one was 3. Now, if you look at the next example, let me erase this here for a minute. Remember what I told you? Ignore this component. Just focus on this part of the scientific notation number. And this one, the answer is 2. Both numbers, the 2 and the 7, are significant. Again, rule number 1. Letter D, we're looking at a conversion factor. Another conversion factor. A centimeter is exactly 0.01 meters. So again, if you have an exact number, which is what a conversion factor shows, the answer is infinite. And then we got letter E. We have a leading zero here. That doesn't count. But then these 2 trailing zeros, there's a decimal point. And because that number has a decimal point, those 2 zeros are significant as well as the 5. So you should have answered 3 for this one. And then the last one, your answer should be 2. And the reason is these 2 zeros, they're trailing zeros, but there's no decimal point. So they're placeholders. Only the 2 and the 1 are significant in that example. Okay? And that will conclude our lesson on significant figures.